Hi dear students, we are going to discuss second ill effect, or you can say bad effect of a hard water on the boiler, and that second ill effect or bad effect is scales and sludges formation. It's a second one because only two bad effects are there. So one by one we are going to discuss. So let us see sludges. Now what is meant by sludges? The slimy and loose deposit. What kind of deposit? Slimy and loose. Who produced that deposit? Salts produced that deposit. That is what the PPT you can say. Now how salts produced precipitate? Because that salts undergo precipitation itself because of high concentration of salts in the boiler water. So simple way you have to define that the slimy and loose deposit of precipitated salts in the boiler is known as a sludges. Okay, so only two keywords are there, slimy and loose deposit. So let us see the causes of sludges formation. As we know that in the boiler water boil continuously. What will happen if water boil continuously? Level of water start decreasing because water continuously converting into vapors. So level of water start decreasing and concentration of salts left behind in the boiler goes on increasing. So what will happen if concentration of salts increases? Because of increase in the concentration of salts, that salts undergo precipitation, right? And that produced precipitate is known as what? Sludge. Okay. Then in cause, simply you have to remember that water in the boiler boils continuously. Because of that, level of water start decreasing and concentration of salts that present in the water goes on increasing. So because of increase in the concentration of salts, that salts undergo precipitation, and that precipitate produced get deposited to the inner side of the boiler in the form of what? Sludge. So precipitate of salt is known as a sludge. Now how to remove sludge and where actually it getting produced? So sludge getting produced in the area of the boiler where flow rate of water is slow. In which area sludge getting produced? The area where flow rate of water is slow. In that area sludge getting deposited, right? So why especially area where flow rate of water is slow? Because sludge itself is loose and slimy. Okay, and it especially form at the area where bends are there, valves are there. How to remove that sludge? Simply by using a brushes. You can use sludge, or you can use detergent solution to remove the sludge, or you can carry out blow down operation to remove the sludges. So simply use the brush or use blow down operation to remove the sludges. Then we will see the disadvantages of sludge formation. Now you simply imagine if sludge getting produced inside the boiler and that sludge depositing to the inner side of the boiler. What will happen if sludge getting deposited to the inner side of boiler? As we are applying heat to the boiler from outside, so the applied heat getting absorbed by the sludge which is present inside the boiler. So here sludge absorb the portion of heat because it is a poor conductor of heat. So what will happen? 100% heat will not be transferred in the water which is present in the boiler. So what will happen? Some portion of heat will waste. So wastage of heat take place here. Simply first disadvantage you have to remember, that is a wastage of heat. Why? Because sludge is a poor conductor of heat. Okay, sludge is the poor conductor of heat. Then second one, if excessive sludge getting produced inside the boiler pipe, what will happen? That produced sludge will reduce the flow rate of water. So water will not flow freely properly because of sludge production. So overall what will happen, it will disturb the working of the boiler. So overall working of the boiler will reduce because of sludge formation. Then third cause, if sludge formation is very high, then boiler pipe will block completely. That is what the choking, or you can say blocking of the pipe, if excessive sludge getting produced inside the boiler. Then how to prevent? As we know that sludge getting produced due to precipitation of salts. So who is responsible for sludge formation? Salt is responsible for sludge formation. So if you want to prevent sludge formation, then use salt free pure water, or you can say soft water which is free from salt, and frequently carry out blowdown operation. Frequently carry out blowdown operation. Blowdown operation means what? Replacing salts rich water with fresh water. Blowdown operation means replacing salts rich water with fresh water, because once you get idea that level of water is decreased, right, or it is decreasing, and there might be a chances of precipitation of salts, then that time you have to carry out blowdown operation. You have to remove that salty water and you have to add fresh new water in the boiler. So in this way you can carry out these two techniques or ways to prevent the sludge. First, simply use soft water, and second, carry out frequent blowdown operation. Then second ill effect we are going to see. Sludge we completed. Now second one is scales. So scales exactly opposite if you compare with the sludges. As we seen that sludges are loose, soft, slimy. So scales are hard and stronger. Scales are harder and stronger. Right. So it is in the form of a coating, and where that coating getting produced. Coating produced inside the boiler. Inside the boiler. Right. How? By chemical reactions. So scales, how to define? The hard and strong coating form inside the boiler by chemical reactions. So strong and hard coating formed inside the boiler by chemical reactions is known as scales. Now what are the causes behind scales formation? So total 4 causes are there behind scale formation, and while writing a causes of scale formation, most of the students simply just enlist the heading of the cause, so it is not allowed. Along with the heading of the cause, student need to write the explanation of that cause along with reaction if it is there. So first cause, decomposition of bicarbonates. Decomposition of bicarbonates means if a bicarbonates present in the water, then what will happen, that bicarbonates decompose into one product, and that product in the form of a PPT. So first reaction you can see, calcium bicarbonate decompose into calcium calcium carbonate, and we know that calcium carbonate is practically insoluble in water and it produces precipitate. Second reaction you can see, magnesium bicarbonate convert into magnesium hydroxide, and that produced magnesium hydroxide in the form of PPT. So these both reactions we already seen in the temporary hardness removal. How to remove temporary hardness? Simply on boiling. Right. So likewise here, decomposition of bicarbonates, that is the bicarbonates decompose, and after decomposition they produce insoluble products, and that insoluble products stick to the inner side of a boiler, and that produces a scale. Second cause of scale formation, hydrolysis of salt. For example, salt present in the water, then definitely that salt will undergo hydrolysis. For example, magnesium salt is there, MgCl2, it is there in the water. So what will happen with magnesium chloride? That magnesium chloride convert into MgOH twice, that is the magnesium hydroxide, and it is in the form of a PPT, and that PPT is a very sticky, that sticky precipitate deposit or stick to the inner side of boiler. Then third cause of scale, right, that is the presence of silica. So what will happen if silica is there in the boiler water? If silica, that is what, SiO2, is present in the water, then that silica react with calcium and magnesium salts. What I'm telling, if silica is there in the water, then it react with calcium or magnesium salts, and after reaction they produce their silicates. Their silicates means silica plus calcium, calcium silicates, silica plus magnesium, magnesium silicates. That produced silicates are insoluble, highly sticky, so it strongly stick to the surface of boiler from inner side. So produced silicates responsible for scale formation. Then fourth cause, decreased solubility of calcium sulfate. So very simple cause, as the temperature increases, solubility of calcium sulfate decreases. As the temperature increases, solubility of calcium sulfate decreases. We know in the boiler, temperature of water continuously increases. So as the temperature increases, whatever calcium sulfate is there in the water, that calcium sulfate become insoluble, and insoluble calcium sulfate produces precipitate, and that precipitate is responsible for scale formation. So simply, temperature increase, solubility of calcium sulfate decrease. So these are the four causes that we seen just now. Out of four causes, in two causes reactions are there, and in two causes explanation part is there. Okay, so most of the time question raised on this point, right, especially on causes, right? So you have to write explanation along with the reaction, right? So these are the scale forming a material, means these are the material that responsible to produce a scale that we seen in the first cause, decomposition of bicarbonate. Second one we seen, that is what, hydrolysis of salt. Third one we seen that the presence of silica, and fourth one we seen that the decreased solubility of calcium sulfate. So here scales are composed of what? That is what the product I enlisted here. First reaction we got calcium carbonate, second we got magnesium hydroxide, third we got product silicates, and fourth we got product insoluble calcium sulfates. So these are the chemicals, that is what actual scales in the boiler. Okay, so this is what the diagrammatic presentation of the sludges and scale. So no need to worry, right, that this diagram no need to draw in the exam. So in exam diagrams will not be asked. Now we will see the disadvantages of scale formation. So first disadvantage is wastage of fuel. So how fuel getting wasted? As we know that scale is a strong and hard coating. So strong and hard coating get deposited to the inner side of boiler, right? We are providing heat from outside. Scales are the bad conductor of heat. So whatever heat we are producing by using a fuel, that 100% heat not getting transferred inside the boiler. So some portion of heat absorbed by the scales, right? So wastage of heat means wastage of fuel. Okay, then second one, overheating of boiler. Now second disadvantage is linked with first one. How? See, because of wastage of heat, 100% heat is not getting transferred inside the boiler. So some portion of heat absorbed by the scale. So here, in order to maintain required pressure of steam, in order to maintain required pressure of steam, we have to apply more heat, or you can say we have to provide more heat. Why? Because some heat scale absorb. So we have to overheat the boiler. We have to give extra heat to the boiler for maintaining required pressure of steam production inside the boiler. So because of extra heating, what will happen? Overheating of boiler take place. Then third disadvantage. Now third disadvantage link with second one. What will happen if we overheat the boiler? It's metal ultimately. So because of overheating, metal of the boiler become brittle, it become weak, right? And once it become weak and brittle, it will be unsafer to use. So boiler safety will be the problem, right, if we overheat the boiler. So overheating make the boiler brittle, weak, right? So there is a problem of boiler safety. Then fourth one, danger of explosion. So there might be a chance of explosion of the boiler. How? Because the time when we overheat the boiler, scale deposition is there inside the boiler, and that scale deposition is not even. You can see the diagram, second diagram, right? That is what the scale hard coating, right? And deposition or coating of scale inside the boiler is not even. In some area more deposition is there, in some area less deposition is there. So whatever steam or pressure getting generated inside the boiler, that pressure is not even on the surface. Why pressure is not even on the surface? Because deposition is not even, it is uneven. So what will happen? Because of high pressure in the boiler, there will be the cracks, or you can say the production of cracks in the scale. That coating will break, there will be the crack in the scale coating. So what will happen, that highly boiled water, right, suddenly will come in contact with the boiler metal. As water enter through the crack, it will reach to the surface of the boiler metal. As we are giving more and more heat to the boiler, that is what extra heating. So here water coming in contact with the boiler through the crack, and because of overheating, extra heating, sudden steam production rate will increase, and because of sudden increase in steam production rate, there will be a high pressure in the boiler, and because of high pressure there might be a chance of explosion. So this is what the danger of explosion. So these are the four disadvantages of scales. Then how to remove scale? Simply use wire brush or a scraper to remove the scale. Second one, use the hammer, as the scales are strong and very hard. So use hammer to remove the scale. Then third one, thermal shocks. Through thermal shocks, you can remove the scales. Or you can add some chemicals like EDTA, sodium phosphate, or calgon. Out of three chemicals, if you add any one chemical, then that chemical dissolve the coating of scale. And once scales dissolve, through blowdown operation we can remove it. Now how to prevent scale formation? As we seen in the causes, right? Hydrolysis of salt responsible for scale formation, right? So best way to prevent scale, use salt free soft water. Okay. Then second prevention, use sodium phosphate. Sodium phosphate we have to use for water treatment. Alright, so if we use sodium phosphate for water treatment, scale formation chances will not be there. Then second thing, carry out frequent blowdown operation to prevent the scale formation. Or you can add chemical sodium aluminate. So sodium aluminate trap the scale forming material, means sodium aluminate will not allow the chemical components to produce the scale. So sodium aluminate trap the scale forming of particles. And last one, you can add organic chemicals like tannin, lignin. So tannin, lignin form coating on scale forming particles. It form a coating on scale forming a particle. Alright, and that coating is very loose and slimy, so that scale forming a particle will not get chance to stick to the inner side of boiler. Okay, so scale forming particles coated with tannin or lignin, and once it form a coating on scale forming particle, we can remove it by blow down operation. So in this way we can prevent scale formation by using soft water, by frequent blow down operation, by adding a sodium aluminate which trap the scale forming particle, or you can add tannin or lignin, as tannin or lignin form a coating on scale forming a particle, and then through blow down operation you can remove it from the boiler. So this is what the sludges and scales. So here we seen the definition, causes, how to remove, disadvantages, and prevention of scales and sludges. So hope you understood. Thank you for watching.